Hi everyone, today we are going to solve a question on waves. Let's read the example. We have two pulses, pulse 1 and pulse 2. They are both traveling with the same speed, but in the opposite direction. The speed of each pulse is 26 centimeters per second, and the unit on the horizontal axis, each unit is 2 centimeters, and each unit on the vertical axis is also 2 centimeters. So because pulse 1 is traveling to the right and pulse 2 is traveling to the left, they are going to meet. So part A is asking for the location at which the resultant wave of the two pulses have maximum amplitude. So I want to know basically where the two pulses meet at their peaks. That's what the question is asking for. Now, what I'm going to start with the units in here. If I look at the horizontal axis, I could label my scaling in here. I could say I have 2 in here, I have 4, 6, because each unit is 2 centimeters. I could have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and then another half a unit to get to the peak of pulse 2, 23. So the distance between the peaks of the two pulses would be 23 minus 4. Yeah, because peak of pulse 2 is located at 23. Peak of pulse 1 is located at 4. If I subtract the 2, I will get the distance between the peaks. So 23 minus a 4, that gives me 19 centimeters. If pulse 2 was not moving, pulse 1 would travel 19 centimeters to get to the peak of pulse 2. Yeah, but because pulse 2 is moving in the opposite direction, then pulse 1 will definitely travel less distance until it meets pulse 2. Because both pulses have the same width, each has a width of 4 centimeters, and they have the same speed, therefore they will travel the same distance until they meet. Okay, so that is very important. They will each travel the same distance until they meet. What distance that would be? 19 divided by 2, which is 9.5 centimeters. Okay, so each would travel a distance of 9.5 centimeter until the peaks meet. When the peaks meet, well, when the two pulses meet, they combine, and the combination is the resultant wave. Yeah, so they each travel at by 9.5 centimeters. Therefore, the solution to part A would be 9.5 plus, because pulse 1 has traveled 9.5 centimeters, then I add 4 centimeters to it, I get 13.5 centimeters. That would be the location of the max amplitude of the resultant wave. Yeah? So pulse 1 was originally located at 4 centimeters, and it's going to travel 9.5 centimeter. Therefore, its final location would be 13.5 centimeters, which is the same as the location of the peak of the resultant pulse. Great. B. They're asking for the time that the resultant of the two pulses have maximum amplitude. Basically, they're asking for at what time the two pulses meet. If you remember in our exam prep session for Prep 101, we said, look, you could assume that one of the two pulses is not moving and the other one is going to travel with the speed of 2v. And so we did it that way. There's also another way to do it. The other way to do it, you could say, look, for pulse 1, the time of travel for pulse 1, t, equals the distance that pulse 1 has traveled divided by its speed. So if I sub in for the distance that pulse 1 has traveled, which is 9.5, and if I divide it by the speed of pulse 1, which is 26, I will get the time where the two pulses meet. Right? So you could also solve it. You get exactly the same solution. You could say, look, you could divide 19 by 2 times the v, like what we did in the exam prep session, and you would still get the same value. Part C, they're asking for the amplitude of the resultant wave. Because the two pulses are upside, they're in the same, the peaks are in the same direction. What you do, if you want to find the resultant amplitude, you add their amplitudes. Now, if I look at the y-axis, since each unit is 2 centimeters, the peak of pulse 2, the height of pulse 2 at its peak, it is 4 centimeters, plus the height of pulse 1, sorry, it's at 4 centimeters, plus the height of the peak of pulse 2 at 6 centimeters. If you add them, you get the amplitude of the resultant wave, the max amplitude of the resultant wave. Yeah? So you're adding them. If pulse 2 was inverted, it was upside down. So what you do when you're adding up the amplitudes, you're actually subtracting them. Why? Because the amplitude of pulse 2 would be negative. Yeah, it would be, for example, -6 plus a 4, that would give you -2. Good. But going back to this example, if you want to find the max amplitude of the resultant pulse, in this case, you're adding up the max amplitudes. Why? Because you're both upside pulses.